Hey, welcome to 23 Degrees Sideways. I'm going to talk a little bit about numbers and number theory and humans and history, and it's just all very much fun right now because people are talking to me about how complicated ounces and gallons and pounds are. And it's really interesting because I think we broke the system by changing it to a base 16 instead of a base 12, but I'll get to that. The United States was the first nation to widely adopt a true, stable decimal monetary system. And even that is something of a lie because we still used eighths, bits, literally a bit is an eighth, 2 bits is a quarter, and a quarter has always been a standard part of our money system. So in theory, we have a decimal system. We have mils, cents, dimes, tenths, and then quarters, halves, and dollars. So we've been based on a dollar with cent being a cent, 1%, 1/100th, 1 centium of a dollar. And we used to use mils. You still see them on gasoline price tag signs in the United States. But it's always a 0.9, so it's kind of laughable. If you look at pictures from previous eras, you'll actually see the difference in tenths of a cent, which is a mil. Okay, Mark Twain wrote about mils, and you probably don't even know what he was talking about. So tenths of a cent, or mils, was actually a significant difference when a dime was a significant piece of silver and gasoline was 32.7 cents per gallon or 32.2 cents per gallon in a different location. That actually made a difference. You know, you'd be buying 10 or 15 gallons. It made a difference because, dollars were days' wages instead of a third of a cup of coffee. So, the values have changed. A cent now is less value than a tenth of a cent or a mil in 1920 something. So, let alone the early 1800s, so 19th century. So we had this idea, which was shared with Francophiles in our founding fathers, who liked the idea of this whole metric kind of system, doing things with a base 10, because we had adopted a numeracy system from the Arabs that was based on 10, base 10. That's not inherently natural. Despite the fact that you have 10 fingers, it's not actually intuitive or natural or the way your brain is programmed to think. Your brain is not programmed to think of holding something with 7 fingers or 10 fingers. You hold something with 1 hand or 2 hands. Your brain actually thinks intuitively in a more or less binary fashion. So, which we'll get into here in a moment, with base 16 and base 12 and base 20 and base 60. So the base 10 thing it's kludgy. It works very well for a specific type of arithmetic notation, number notation, but there's nothing inherent to that means anything, okay? Octal or hexadecimal, if you can learn to think in them, work just as well, 9 is 8, carry the 1 and a 0. Easy. It's just the same stuff. There's nothing intuitive or necessary about the 10 that makes it work better. You've been taught that this is wrong, that base 10 is inherently, objectively, somehow, intuitively, objectively, rationally, scientifically better, but it's not. It's just a kludgy, arbitrary decision. I'm not arguing that you shouldn't use it because people all over the world use it, but it would be worth understanding what some of the other bases are, why they work, how they work, and just expanding your brain a little bit. because you can get stuck with a way of thinking that disallows common measurements because they don't fit nicely into base 10. Eighths, for example, do not fit nicely into base 10, nor do sixths. But those things actually are very real. So, for example, a bit. Remember the piece of 8 and then bits? 1/8 of a specific coin, 1/8 of an ounce of silver, for example. This isn't the example. The coins were not exactly ounces the way we think of them, but 1/8 of a coin. It's very easy to cut a coin in half. It's very easy to cut it in quarters. It's very easy to cut it in eighths. 1/8 is a amount of money. It's a recognizable amount of money. And this was actually used and done quite frequently throughout history, especially in the New World. And that's why we still have a quarter. We still have the quarter as a primary, probably the primary coin in American currency is the quarter. And kicked my tripod. Got to do that every time. So why base 16? Why base 12? Why do we talk about it? What's going on? Well, I don't actually know why we have base 16. We use ounces in fluid measure, ounces in cups, fluid measurement. We use ounces in pounds for mass in the United States and a couple other places. We use standard American measurements versus imperial. There's a slight difference. Roughly speaking, very roughly speaking, accuracy has changed things a little bit. Now, one thing to note is that the metric system changes. 1 gram of water today is not the same as 1 gram of water in 1820. It does actually change as we develop our ability to measure things. Air pressure, temperature, things. Roughly speaking, 1 ounce of water weighs 1 ounce. Technically, because of drift and accuracy of measurements, 1 ounce of water weighs 1.04 ounces. Okay, it's off by just a little bit. You could just adjust the standards like you do with metric and it would make perfect sense. So an ounce is an ounce, just like a milliliter is a milligram. Okay, no real difference. Or centiliter? A gram is a centiliter? Whatever. No, a gram is a milliliter. Yeah. One of the problems with metric is that they don't use the same place values for everything. A gram is not the equivalent of a liter. A gram is the equivalent of 1/1000th of a liter. So 1,000 grams is a liter, whatever. That's bizarre, crazy, somewhat stupid, and very arbitrary. So originally, we did not have 16 ounces in a pound, and we did not have the way we measure cups now, cups and pints. Originally, this measurement comes from Rome, and the ounce is a Roman measurement, and there were 12 ounces in a pound. Makes perfect sense. 12 is a very intuitive number to base things on. You have halves, you have quarters, you have thirds, very easy without doing any weird things where you have to chop numbers in half or do eighths. 0.125 is an eighth of 1, but an eighth of 16 would be 2. Stuff like that. Base 12, you can do a quarter or a third very easily. A third is 4, a quarter is 3, half is 6. It's very easy to do this stuff and bring it down. 1/6 is 2. You can cut things in half more often before it gets really weird. Base 12 works with base 20 and base 60 intuitively and broadly. I'm not going to get too far into that because most people don't actually get into external mechanical stuff these days. So 360 degrees in a circle doesn't mean anything to anyone. The idea of base 60 degrees, base 20, it doesn't really speak to people unless you're in a trade. If you're in a trade, it actually does make a lot of sense and it's very intuitive. And that's one of the things that you'll find if you do common rafters or if you're working on construction, landscaping, or surveying in any sense, is that most of these numbers actually have a lot of sense and intuitive manipulation, because they're all based on things that really work with thirds and quarters and halves and powers. 12 times 12. The gross, dozen. It's all very simple stuff. So, and of course 12 times 5 is 60, which is 3 20s, band base 60, and so on. And I'm not going to talk about that too much more because the multiple bases doesn't usually, it's a little complicated for people who have been dumbed down by the decimal system. For unknown reasons, we switched from base 12 to base 16 somewhere in European history, and it makes no sense whatsoever historically. But it is kind of interesting in that it is just a binary system. And for the last several decades, there's been an ongoing argument about how we need to do things in binary to work with the computers and computing infrastructure. So binary has become a big deal. Binary math, octal math, that's base 8, hexadecimal, which is base 16. So again, here we have 16 ounces in a pound. So that's just base 16. That's just binary. It's just binary done to a power of 4. 8 is the power of 3. There used to be 4-bit processors, which I won't even talk about because that just dates me, and I'm obviously Gen X. So yes, I have done machine language programming for 4-bit Saturn processors. Octal, 8. That's very basic. 8-bit computers were a thing for a long time, and 16, 32, 64-bit computers. We spent a lot of time telling people that they needed to handle this, that they needed to adapt themselves to this, and that it was really easy. And the truth is, it's really easy. It's not intuitive. It's not real. Okay, it's just an arbitrary thing that we do because computers like to work with binary instead of decimal systems. If you really were attached to decimal, we would still be using BCD, binary coded decimal. No one even knows what that is, but we used to use it, and it used to be how we calculated really deep physics because it's more accurate than trying to do math with binary, especially this is computer science stuff that goes back to the 80s and no one even knows anymore because the coders in Gen Z don't actually know what binary is. They don't know what a breadboard is either, right? So, whatever. Iron core memory, we used to do this stuff at home, make little magnetic memory cores. There are 2 tablespoons in an ounce. So there are, realistically, 16 tablespoons in a cup. A cup is 8 ounces. It's a perfect measure. It's a very reasonable measure. You can hold a cup. It actually makes a lot of sense in that sense. I don't know why we're using base 16 instead of base 12. But again, you can hold a cup. It's pretty easy. 16 ounces is a fist of water in a bottle. It's very simple. It really is simple and intuitive. But it's also very easy to manipulate because everything is doubled or halved. Everything is doubled or halved, okay? A pint is 2 cups. Obviously 16 ounces because you're just doubling 8 ounces, right? Duh! Weighs a pound. Duh! Right? A quart, 2 pints, 4 quarts to a gallon. Gallon is 128 ounces, which happens to be 256. That's a magic computer number, 256 tablespoons. But 2 gallons, which used to be more of a thing. Historically, 2 gallons as a measure used to be more of a thing than it is now. But that's 256 ounces. It's very simple stuff to really look at. It's very simple math. And then, so a gross, 144 ounces, just over a gallon. But you can do the math here. You can measure it out and do things different ways. It's very interesting to note that if you play with it, if you touch it, if you feel it, if you look at it, if you hold it, if you combine, if you do things in half and you do things in doubles, it's very intuitive. It is actually much more intuitive than, for example, a fairly common measure is 330 milliliters, 33 centiliters. It's roughly equivalent to the it's the bottle of water size, right? So it's much easier to deal with 16 ounces, which is not quite that, than it is 330 milliliters. 330 is 33 100ths of, a liter, but that doesn't math well. It doesn't double or half very well. What's half of that? What's half of 33 100ths of a liter? 16 and a half, 100ths of a liter. This is somehow easier for people than figuring out half of 16 ounces is 8 ounces. Whatever. I don't believe it. I think that people are just kind of attached to this because there's this idea that you are somehow objectively more scientific if you adopt the proper religion and do things in all decimal. Nothing could be further from the truth. So base 12, base 20, and base 60 actually work with the human brain, human experience, much more intuitively once you get used to using them. I'm not suggesting that you go change your life or anything, but before you start putting people down, like our temperature system, Fahrenheit is based on it's really hot and it's really cold. If you look at human living temperatures in a temperate zone, 100 is pretty hot and doesn't usually get much hotter, and 0 is pretty cold, doesn't usually get much colder. That's Fahrenheit's system was based around human experience. Very intuitive. Okay, yes, water freezes at 32 degrees for some odd reason that just happens to be where it was, but water isn't what it's about. Human life is what it's about. And that's kind of a core thing. The centigrade system, what used to be called the Celsius system, but is now the centigrade system because Celsius was apparently a dick. The centigrade system is based on the idea that water, when water freezes, a certain purity of water at a certain atmospheric pressure in certain environments, when that freezes, that is the absolute measure of reality. If you change anything about the water, the pressure, your altitude, air pressure, anything, it doesn't work. So, I don't know, it's a kind of a very arbitrary thing. Like everything in metric is very arbitrary. It doesn't have any real meaning. The metric system was set up to be close enough to the older imperial system that it was annoying, but not really too different. Like people could still figure it out. Like a meter is close enough to a yard. They could have made the meter in exactly the same length as a yard and divided it up into 100 chunks. No problem. But they didn't, because they had to be different. So there's this idea that has grown from this that you're somehow stupid or lesser if you use an intuitive system than if you use an arbitrary system that doesn't actually work with human bodies or brains. On the other hand, I don't know, maybe some of you have 10 hands. Stay sideways.